Hi everyone, my name is Erica with L&L 3D Solutions, and in this upgrades and tips video, we'll be showing how to install a Euclid probe. Let's get started. No build plate surface is ever perfectly flat. It has high and low points that, if not accommodated for, can affect the first layer, causing problems like layer adhesion issues, warping, and uneven bottom layers. A Euclid probe checks points on the print bed to find and measure the differences in these high and low points. Once found, the printer can then accommodate for these high and low spots, creating a perfect first layer, resulting in a smoother and more accurate print. In utilizing these Euclid probes, we have found the outcome of each print to be consistent in accuracy, and we want to share this tip with you. Soon, these Euclid probes will be available as an upgrade kit on our website lnl3d.com. So let's install it. First, you'll need a driver with a 2.5mm hex bit or Allen key, two M2.5 screws no shorter than 6mm, one of our JST pinout cables with a 2-pin connector and a 3-pin connector, an assembled Euclid probe docked in the mount, a piece of paper, a pen or marker, and a piece of masking or painter's tape. First, we're going to home the printer and make sure your nozzle and bed are at cold or room temperature. Now you can move the E1, Z, and X axes to where you're comfortable working with it. Then we'll remove the left metal scraper so it's not in the way. We're then going to turn the printer off and turn it around and remove the 2 screws attaching the shroud, disconnecting the cables. We can put that aside for now. Now, taking the Euclid probe, separate the 2 boards held together by magnets. You'll notice on the board attached to the dock 3 metal pins, 2 of which are labeled ground and signal. The 2 pins on our JST cable will be aligning with these 2 ground and signal pins. JST cable pins will be inserted into the 3-pin connector, and the 3-pin connector will be inserted into the back of the Euclid probe dock. So when we insert the JST cable pins into the 3-pin connector, we want to make sure we wire it aligning with the ground and signal pins. So first, insert the 2 JST cable pins into the 3-pin connector on the side where the ground and signal pins will be. Then take the 3-pin connector and insert it into the back of the probe dock. Now we can go ahead and take our 2 M2.5 screws and mount the probe to these 2 bottom screw slots here. Then take the pinout cable and connect it to the DJ pinout. Now you can attach the other half of the probe, turn your printer back on, and we'll go ahead and home the unit again. From here, we'll move the tool head up a bit and move the tool head as close to the center of the bed as we can. If we know the position, we can use a G-code command to accomplish this. Now we can take a piece of masking tape and place it underneath where our probe is. Now we're going to run the command probe. It will then probe the bed and leave the probe docked. Then we can take our pen or marker and mark the edges of the probe and also the position of the probe clicker. Now we can move the Z up a bit and finish connecting the markings together, making a full box, and finish marking the position of the probe clicker. Now we'll take the probe off and try to slowly move the nozzle to this cross position. Now that the nozzle is in position, we'll run the command get_position or check our toolhead position information. It should match. And we're looking for our stepper X and stepper Y position. So we'll write both of these down. Stepper X, Y, 146, 149. When we look at our probe position from earlier, we were at 150, 150. So we'll write that down as well. Probe XY, 150, 150. Now we'll take our nozzle position, our stepper XY position, and subtract our probe position. So then we'll write nozzle X minus probe X, 146, minus 150, and that equals -4. Then under that, nozzle Y minus probe Y, 169, minus 150, equals 19. So now we know our probe offset x and y is -4x and 19y. Now we're going to go back to our printer, click on Machine, and we're going to look for our config, whether we're 32-bit or 8-bit. Under Params, and this is a 32-bit machine, we're looking for the probe 32-bit config file. We can see that our x and y offset is not correct, so here we'll add our x offset, which was -4, and our y offset was 19. We want to make sure our z offset is commented out so Clipper can calculate this itself. Now we'll click Save and Restart. Now that we've done this, we'll go back to Dashboard and rehome our unit again. We'll now reattach the probe and remove the tape. And now we want to calculate our probe's z offset, and for that we'll use the Clipper pad. So first we'll go to Move and move our z up just a bit, and then the same as before, we're going to move our tool head towards the center. Then we'll take our piece of paper, starting without the probe in a cold or room temperature bed. We'll go back and tap More, then Z calibrate, Start, and then End Stop. Now we're going to slowly lower the nozzle and do this as if we were doing a paper leveling test. Then we'll tap Accept and Clipper will then reboot. Then we'll need to home our unit again and reattach our probe. Then we can go back and go ahead and move the Z up a bit, go back to More, Z calibrate, Start, and then Probe. The machine will move the probe to the center of the bed, probe a few times, and then it will move to that -4 and 19 position, and the nozzle will be right around where we just probed. We'll detach the probe again, put back our piece of paper, and repeat the same process we did for the end stop. We'll lower the nozzle and do a paper leveling test again. Now that it's set, we'll tap Accept and Clipper will reboot, and we'll home the unit again. And now our probe is all set up. Now we can reinstall our shroud exactly the way it was, with the cable that goes to the center fan connecting to the F2 pinout, and our side fans connecting to the FC pinouts. And that's how to install a Euclid probe. Again, these Euclid probe kits will be available soon on our website, so stay tuned for that. We're L&L 3D Solutions. Follow us on all our socials and feel free to reach out if you have any questions. Happy printing!